So we are given the piecewise function of f of x being equal to ax squared plus 10 when x is less than 2, and x squared minus 6x plus b when x is greater than or equal to 2. And we are tasked with finding a and b so that f of x is differentiable and continuous at x equals 2. So we can start by figuring out if it's continuous or not by setting the limit as it approaches from the left equal to the limit as x approaches 2 from the right. So our limit from the left will be the limit of ax squared plus 10 as x approaches 2. And from the right will be the other part of the piecewise function, that being x squared minus 6x plus b and its limit as x approaches 2. So solving both of these down, we get the limit as x approaches from the left to be 4a plus 10, and the limit as it approaches from the right being negative 8 plus b. And now we have to set these equal to each other, as that will tell us if it's continuous or not. And now we can move over to figure out if it's differentiable by setting the derivatives of both of the piecewise functions equal to each other. So the derivative of the ax squared plus 10 is 2ax, and the derivative of x squared minus 6x plus b is 2x minus 6. And now we have to set these equal to each other to figure out if it's differentiable or not. And we can plug in 2 for x as we are figuring if it's differentiable at x equals 2. And now we have 2a times 2 equals 2 times 2 minus 6. And solving that down, we get 4a equals negative 2. And then we divide 4 by both sides to isolate a. And a ends up being negative 1/2. Now we can take this a and go back over to where we found if it was continuous or not to help plug that in to solve for b over here. And we plug in negative 1/2 for a, and we get 4 times negative 1/2 plus 10 equals negative 8 plus b. And solving this down, we find that b equals 16. So now we have a and b, and all we have to do is plug it back into our piecewise function to get negative 1/2 x squared plus 10, where x is less than 2, and x squared minus 6x plus 16, where x is greater than or equal to 2. And we're done.